Hello, good evening. Yeah, my name is Samson, and tonight I would like to take you through a very short trial question. Now, this question talks about a reaction between an acid and a base in a titration form. Now, he said that the student is given 50 ml solution, 50 ml solution of nitrous acid. So the volume of the nitrous acid is 50 ml and the concentration of it is also 0.15 molar. Now it was added to, okay, so they gave us the pKa of the nitrous acid also as 4.0 by 10 to the power negative 4. Now, then we're also giving the volume and the concentration of the volume of the base as 25 ml. Then the concentration also as 0.10 molar. Now, this is a reaction between a weak acid and a strong base. So, for the net ionic equation, some of these will dissociate, but all of these will dissociate. So you have something like this. Your net ionic equation, you have something like this. Now, this is the general equation. However, since part of this is dissociating, all of this is dissociating and part of this is dissociation, you have your some of the nitrous acid still left, but since this is a spectator ion, this is a spectator ion, it will cancel out, giving you N2 minus plus water. So this is the first part of the question. This is the ionic equation that you are supposed to get. Now, the second part of the question is asking us to calculate the pH of the solution. To get the pH, we first need the concentration of the hydrogen ion, which is given as KaC, where Ka has been given and the C of the nitrous acid has also been given. So the concentration will be 4.0 by 10 to the power negative 4 times 0.15, which should give us something around 7.74 by 10 to the power negative 3 molar. Now that we know the concentration of the hydrogen ion, we can go on to say that pH is equal to negative log of the concentration of hydrogen ion. Now we put this concentration here, and that should give us, per the calculation, we should be getting 2.1 as our pH. Alright? Now, so let's look at the second part of the question. The second part also says that we should calculate if we should. Now, the second part says that the student add 25 ml of the sodium hydroxide. So this one to this. So when you add, now let's look at the volumes that were the number of moles of each of the solutions. So number of moles of the nitrous acid will be the concentration times the volume. The concentration is 0.15 and the volume is 50, so we'll convert it 0.05 liter. So when we multiply, it should give us 0.0075 moles. Now the number of moles of the sodium hydroxide, also the same format, alright, also the same one. So we need a concentration which is 0.0110, sorry. Then the volume is also converted, 25 ml is converted, which will give us 0.025. And that should also be given as 0.0025 mole. Now, since there is more of the acid left and all of the sodium hydroxide is consumed, it means that this one determines the amount of the NO2 formed. So we can go on to say that number of moles of the nitrous ion is equal to the number of moles, since the mole ratio is the number of moles of the sodium hydroxide. Therefore, we can say that N of the sodium, the NO2 minus, is equal to 0.0025 mole, and that will be the number of moles of the nitrous ions produced.